In physics, potential energy, often represented by the variable U, is the energy stored within an object because of its characteristics or position. There are 5 different types of potential energy: chemical energy, or the energy stored in molecular bonds; nuclear energy, or the energy stored in fundamental particles of the universe, such as protons, neutrons, and electrons; electrical energy, which is energy stored when charge is separated; and the 2 most important that we have focused on this year, elastic and gravitational potential energy.
Elastic energy is energy stored in springs or spring-like material. In this example, when a bungee cord is pulled from one end, it is stretched in the middle, generating elastic potential energy. The formula for elastic potential energy is USP equals 1/2 kx squared, where k is the spring constant and x is displacement from equilibrium. Gravitational potential energy is stored in objects that have the potential to fall under the influence of gravity. This ball has gravitational potential energy because it can fall. The formula for gravitational potential energy is UmG equals mgh, where m is the mass of an object, g is the acceleration due to gravity, and h is the height of the object.
Kinetic energy is the energy generated through motion. Any moving object has kinetic energy. The formula for kinetic energy is k equals 1/2 mv squared, in which m is the mass of the object and v is its velocity. Objects with greater mass and higher velocity will inherently have more kinetic energy. In this example, Nick throws a 57-gram tennis ball at 3.5 meters per second. This means the ball has 0.35 joules of kinetic energy in motion.
Potential energy can be converted into kinetic energy. Going back to the tennis ball and bungee cord examples. When the tennis ball is dropped, its gravitational potential energy is converted into kinetic energy as it accelerates towards the ground. Similarly, as the bungee cord is released, its elastic potential energy is converted into kinetic energy as it naturally returns to equilibrium through motion.
The work-energy theorem states that the total work done on a particle is equal to its change in kinetic energy. For example, a basketball at rest on a slope currently has kinetic energy equal to 0. However, if it is released from rest and arrives at the bottom of the incline with a positive velocity, it has generated kinetic energy through motion.
Because the ball had an initial kinetic energy of 0 and a positive final kinetic energy, work must have been done on the object. Through the work-energy theorem, we can determine that the work done on the object by gravity must equal the change in kinetic energy.